Welcome to the DIY Honda Garage channel. In this presentation, we will explore DTC P2827, which indicates a high input from the line pressure solenoid valve A in the Honda Pilot models from 2016 to 2022. This diagnostic trouble code, DTC, suggests that there is an electrical circuit issue rather than a mechanical one within the transmission system. The line pressure solenoid valve A plays a crucial role in controlling the hydraulic pressure needed for shifting gears properly in automatic transmissions. Its location is usually found within the transmission assembly, connected to the powertrain control module, PCM. The PCM is responsible for monitoring the signals sent from various sensors, including solenoid valves, to ensure the transmission functions correctly. Understanding this DTC is key for effective troubleshooting, allowing us to maintain the vehicle's performance and reliability. DTC P2827 signals a high input from the line pressure solenoid valve A, which is integral for regulating transmission fluid pressure. The solenoid valve's function is to control the line pressure that the transmission relies on to shift gears smoothly. If this valve is not functioning correctly, it can lead to erratic shifting, poor performance, and even potential damage to other transmission components. The valve is typically located inside the transmission assembly, connected to the PCM via wiring harnesses. This connection is essential for the electronic control of the transmission. Notably, this error code specifically points to an electrical problem rather than mechanical issues within the transmission, which is a crucial piece of information for effective diagnostics. When addressing DTC P2827, it is essential to consider several potential causes. The first could be a faulty line pressure solenoid valve A, which directly affects hydraulic pressure within the transmission. Alternatively, an open circuit in the wiring that connects the solenoid to the PCM can lead to high input signals. Additionally, a blown fuse, specifically fuse C7 rated at 15 amps, could cause this issue by interrupting power flow to the solenoid. Each of these causes can lead to the symptoms associated with this DTC, and identifying the correct one is vital for successful resolution of the issue. Therefore, thorough inspection and testing of these components and circuits should be performed methodically. Symptoms associated with DTC P2827 can significantly affect vehicle performance. One of the most noticeable symptoms is erratic shifting behavior, which can lead to a jerking sensation while changing gears. Drivers may also experience delayed engagement when shifting from park to drive or reverse, causing concern for safety and operation. Furthermore, the vehicle's onboard diagnostics may trigger the transmission warning light on the dashboard, alerting the driver to a problem in the transmission system. These symptoms are not only inconvenient. If left unaddressed, they could lead to more serious transmission damage over time. Therefore, recognizing these symptoms is crucial for taking timely action. The first troubleshooting step for DTC P2827 involves verification of the problem using Honda's HDS, Honda Diagnostic System. Start by turning the vehicle to the on mode, ensuring that all systems are activated for diagnosis. Next, clear the DTC using the HDS to reset the system's error codes. After clearing the DTC, you must start the engine while the vehicle is in Park P mode and let it idle for at least 1 second. This allows the engine and transmission systems to stabilize and communicate with the HDS. Finally, check whether any pending or confirmed DTCs have reappeared in the system. If DTC P2827 is indicated again, we proceed to the next troubleshooting step. Conversely, an absence of DTC indicates an intermittent failure that may require further inspection of electrical connections and terminal integrity. For the second step in troubleshooting DTC P2827, you must first turn the vehicle off to ensure safety. The next task is to check fuse number C7, which is a 15A fuse located in the under-dash fuse relay box. This fuse is important as it can directly affect the power supply to the line pressure solenoid valve A. If the fuse is intact, you can conclude it's working properly and you should proceed to the next step. However, if the fuse is blown, replace it and confirm whether the issue persists. If the new fuse blows again, that indicates a short to ground in the circuit that will require careful inspection and repair. Addressing fuse issues can often resolve DTCs effectively without requiring further invasive diagnostics. In this troubleshooting step, you will check the IG1 VBSOL line for continuity and proper signaling to the PCM. Start by jumping the SCS service check switch line with the HDS and wait for more than 1 minute to ensure the system is ready for testing. After that, disconnect the PCM connector B, specifically the 51P connector, which is crucial for communication between the PCM and the line pressure solenoid valve A. Turn the vehicle back to the on mode while the PCM connector is still disconnected. Next, measure the voltage between the designated test points. Test point 1, located at PCM connector B, number 1, and body ground as test point 2. If you find battery voltage at these points, it suggests the IG1 VBSOL wire is functioning correctly, allowing you to move on to the next troubleshooting step. Otherwise, it indicates an open circuit that requires attention. For troubleshooting step 4, you will focus on determining whether there is a problem with the line pressure solenoid valve A or related components. Begin by turning the vehicle to the off lock mode for safety. Then, reconnect the PCM connector B before disconnecting the line pressure solenoid valve A 2P connector. Connect terminals A and B of the solenoid with a jumper wire to provide a direct ground. With this setup, turn the vehicle to the on mode again and clear any previous DTCs using the HDS. It's essential to raise the vehicle securely and allow the wheels to rotate freely while testing the accelerator position. Monitor the APP, accelerator position sensor readings on the HDS, checking them for any abnormal variations. After completing this step, check for new pending or confirmed DTCs. If a DTC P2827 appears, it indicates a need to further investigate the solenoid. If no new DTCs are found, proceed to the next step. For this troubleshooting step, focus on checking the continuity of the line pressure solenoid valve A, following the previous procedures. Start by turning the vehicle to the off lock mode and then remove the jumper wire used in previous tests. With the line pressure solenoid valve A 2P connector still disconnected, verify continuity between test points 1 and 2. Test point 1 is at line pressure solenoid valve A 2P connector number 2, while test point 2 is connected to body ground. If you find continuity between these points, it indicates a fault with the line pressure solenoid valve A itself, which necessitates replacing the secondary valve body. On the other hand, if continuity fails, it suggests the valve is functioning properly, but further investigation of the wiring is needed. This may involve checking the PLA, pressure line actuator wire, back to the ground, point G101. In the final troubleshooting step, the focus is again on the PLA line, determining if there are any open circuits that could contribute to DTC P2827. First, turn the vehicle to the off-lock mode and remove any jumper wires to ensure no interference during testing. Once the SCS line is shorted with the HDS, disconnect the PCM connector B51P once more. With both the line pressure solenoid valve A2P connector and the PCM connector B disconnected. Check for continuity between test point 1 at line pressure solenoid valve A, 2P connector number 1, and test point 2 at PCM connector B, number 5. If continuity is confirmed, it denotes that the PLA wire is intact, indicating a potential fault within the PCM itself, which may require replacement. Conversely, if continuity is not present, this confirms an open circuit in the PLA wire that must be repaired to rectify the issue. Once all troubleshooting steps have been completed and necessary repairs made, the final repair verification is essential to ensure that the issue is resolved. Begin by using the HDS to clear any stored DTCs, especially DTC P2827, from the PCM. It's critical to take the vehicle for a test drive to allow the transmission system to operate under real-world conditions. During the drive, pay close attention to how the transmission shifts, ensuring smooth transitions without any slipping or erratic behavior. After the test drive, monitor the system using the HDS to check if any DTCs reoccur. If the DTC P2827 does not return, it indicates that the repairs were successful. However, should the code appear again, further investigation may be required to pinpoint underlying issues not previously addressed. Once you have successfully resolved DTC P2827, consider implementing preventive maintenance strategies to avoid future occurrences. Regularly check the transmission fluid levels and condition. Contaminated or low fluid can lead to malfunctions in the solenoid and overall transmission performance. Additionally, inspecting electrical connections periodically can preemptively identify any corrosion or loose connections that might lead to intermittent faults. Keeping an eye on the dashboard for warning lights related to the transmission is also crucial, as they serve as an early warning system. Moreover, conducting routine diagnostic checks with the HDS may help catch potential issues before they escalate into problems that trigger DTCs. This proactive approach will enhance vehicle reliability and extend the lifespan of the transmission system. In conclusion, DTC P2827 signifies a high input issue with the line pressure solenoid valve A, primarily stemming from electrical problems rather than mechanical ones. Recognizing the essential role of the solenoid and understanding its location and connections within the transmission system facilitate effective troubleshooting. The diagnostic process outlined focuses on systematically identifying faults, from checking fuses to inspecting wiring and solenoids. Successful resolution not only improves transmission performance, but also reduces the risk of further complications down the line. Lastly, implementing preventive maintenance strategies plays a crucial role in ensuring long-term reliability, helping identify issues before they escalate. By being proactive, drivers can maintain their Honda Pilot's performance and reliability for years to come. Please like and subscribe to the channel. See you next time.